Welcome to the Teachers to Tech podcast. I'm your host, Dean. This is the podcast where we tell you how you can grow your tech skills, whether you're starting from scratch or just want to go farther. You might be thinking about a new job, a whole new career, or just a new hobby. We'll have something for everyone, so keep listening. Welcome to episode 111 of Teachers to Tech. Today's episode will do more than just educate you. It should also contradict some nightmare scenarios that make it into the media from time to time. Because today we're talking about robots. If you've been led to believe that the robots are going to take our jobs, this episode will change your mind. I've been looking forward to this episode for a while because I've spent a bit of time working with industrial robots. Let's make sure we all have a good understanding of the term robot. Most industrial robots in use today aren't the human-shaped androids that we see in the movies. Industrial robots could more accurately be described as arms. Like your own arms, they can move into a variety of positions and they can hold a variety of work pieces or tools. Imagine yourself in a kitchen making a sandwich. One hand might hold a piece of bread, which could be compared to a work piece, and the other might hold a knife loaded with mustard for spreading on the bread. The knife could be compared with what we'd call end-of-arm tooling in robotics, and both arms can move to bring the work and the tool together at appropriate angles to each other. Then the arm with the knife continues moving in a spreading motion. This is a pretty solid picture of how an industrial robot works. So if the robotic arm emulates the human arm, what are the advantages of using robots for certain jobs instead of just using humans that already have arms? Well, I made a little list here, and first of all, there's speed. We've got some pretty fast humans on certain jobs, but I doubt if they can beat the thousands of millimeters per second that a robot can move its arm. And then there's payload. There are robots out there that can lift a vehicle, a fully built vehicle, which is not common in humans. Then there's reach. It's very easy to build a robot that can reach far greater distances than a human arm can. And it can reach into things that a human arm shouldn't, such as areas where there are flames or high heat, areas where there is a lot of cold, areas where there are cutting tools or moving heavy parts. Then there's accuracy. Robots are capable of being controlled down to a fraction of a millimeter and timed down to a fraction of a second. We get them where we want them, when we want them, and they repeat that performance over and over again. Which brings us to our next point. Robots do not get repetitive injuries the way humans do. Yes, they require maintenance. Yes, they have wear and tear. But if they're programmed and maintained correctly, they will last a very long time, and we avoid having humans get repetitive stress in elbows and backs and other joints. And this way we save a lot of trouble for humans. And I mentioned this when I talked about reach. Robots can operate in environments where humans do not belong. It could be because of heat, it could be because of sharp tooling, it could be because of cold, it could be because of heights or weight or a lot of other reasons. The robots can take over, and humans can stay back from the work where they belong. Some of the common tasks that we will expect robots to complete for us include spot welding, arc welding, paint application, and if that doesn't sound very dangerous to you, the paints that are used in automotive and other environments are highly volatile until they are cured, and the robots will operate in those environments built in a special way to be safe, with no harm to humans from combustion or, by the way, fumes. We can also use robots commonly for sealing and adhesive applications in vehicle builds and other situations. We also use an awful lot of robots to just plain pick up things and put them somewhere else. Hey, I have just completed filling this carton with tortillas, send it down the conveyor, and at the other end of the conveyor is a robot that will grab it and put it on a pallet for shipping to a store. So basically, if you are hearing from me a lot of hard, heavy work being done accurately in a hurry, saving humans a lot of menial toil, then you are correct. So maybe at this point you're saying, well, Dean, so far you're telling me about the robots doing jobs, and they are taking jobs away from humans. Tell me about the jobs they create for humans. I'm going to do that in a little bit, but first we need to talk about how the robots work. So when we come back, we'll do that, and then we'll get into the jobs specifically that teachers or other non-technical people might want to get into first when they move into technical work. So how do industrial robots work? Well, let's continue with the analogy of the arm we were using before. A robotic arm can reach various positions because it has joints. These are hinge points in the arm, and they're used to set the arm at specific angles. These are driven by motors, and those can be computer controlled. They're called servo motors. Programming these is accomplished by different means. It's depending on the model of the robot, but the point of the programming is partly to get the robot to the desired position or to get it to move along certain paths. These positions and paths are created by calculating the exact amount of power to be sent to every servo motor at all times. That's a lot of calculations. Robots generally have an operating system that can make these calculations, but each robot will still need to be programmed for its specific task. And what I mean is, even though a company purchases a robot that is capable of lifting a 50-pound bag of cement, let's say, we've still got to have that installed and taught, hey, the bags of cement are over there, go get them and bring them over here and set them down on this pallet. The robot can also send and receive signals. These are referred to as inputs and outputs, and they allow the robots to interact with each other and with other machines. This is how we can automate an entire process. We can take stages of that process and trigger back and forth between different machines by timing signals to start and stop each of our operations as we need them. Here's an example. A robot might carry a spot weld gun to a part. When it gets to the part and gets to the point where it needs to weld, it can signal out to a weld power supply to say, please deliver the current over the specified time that you've got. And when that weld supply is done sending that weld power, it can signal back to the robot, hey, I'm good, you're finished, move on to the next weld. In our example with the cement, we might have a sensor at the end of a conveyor, and when the bag of cement gets to the end of that conveyor, the sensor says, hey, there's a bag here. The robot now has a signal to move over to that conveyor, pick up that bag, and move it to our pallet. And by the way, that's called a pick-and-place operation. At this point, you may realize that automation extends far beyond the robots themselves. There are sensors and communication devices, controls, and safety equipment all involved. That's just to mention a fraction of the devices. All of these have to be designed, manufactured, sold, installed, and maintained by someone. And who's going to train those people? Well, that's what we're going to get to when we come back. This is the part you've been waiting for. This is the part where we answer the question, hey, how does this apply to me? Remember, it's about my career. We're going to talk about the kinds of jobs that robots generate and how to get ready for those. Robots have to be designed, they have to be built, sold, installed, programmed, and they have to be serviced from time to time. Customers who own robots have to be trained in them so they can maintain them and they can program them. Now, because they're highly specialized and they do complex work, each type of robot has got all kinds of people involved in designing it, in installing it, in adding all the add-on equipment that's going to help it do its job. On top of that, robotics is a business, and that means we're going to have support staff. So that could be facilities people, that could be human resources departments. Remember that earlier this season, we differentiated between working on tech, working with tech, and working around tech. You probably heard examples of each type of work when I gave you that last list. Robots do offer jobs for every point on that spectrum, and they give you the ability to move between jobs as well. When I started Teachers to Tech, of course, I mostly had teachers in mind, and then I would publicize that other people who want to learn tech easily could join us and benefit. But I want to think about teachers again specifically here, and what's the most closely related work to teaching that would apply to them in robotics? Well, that would be technical training. Robot manufacturers and high schools and colleges all offer classes related to programming and maintaining robots. Now, some of you might be thinking about moving away from the public school environment, but there are plenty of training jobs available in robotics through manufacturers and other people who are related to the field rather than public education. In some cases, the jobs don't require full knowledge of the robots before you start. You can get hired in as a technically competent teacher and then learn the robots as you go. But you're going to want to have some experience with technical items. That way it won't be too big a shock if you try to train on robots, and you'll know what you're dealing with. So we'll take a minute and talk about some ways to get yourself prepped for the robotics field. One great way to get started would be to get an Arduino starter kit and work through all the experiments. You'll likely be learning about inputs and outputs in almost all the experiments. You may also work with servo motors, which you know are widely used in automation because I mentioned that before. You'll have precise motion control even with your little experiments. You'll also get a look at some simple programming techniques and probably get a peek at a couple of programming languages like possibly C, C++, or Python. Some experiments may familiarize you with analog, digital, and other types of signals and power. The kits themselves will contain electronic components, and you'll learn their names and you'll learn their functions in a very painless, leisurely format, kind of one piece at a time. There are also plenty of project kits available that offer electronics in a snap-together format. That lets you create multiple circuits and you're reusing the same components over and over again. And I know these kits are usually targeted at young people and teens, but look, if you're willing to learn, this is a great way to do it. It's well worth it. And I'm going to put a link in the show notes to one company's product line that may help you out. Another method of learning about the work done by the robots is to watch plenty of videos published by the manufacturers and integrators. Integrators are companies that create operations that may involve robots along with other equipment. It's all planned and coordinated together to get a job done. For instance, a conveyor belt may carry a box along a conveyor, signaling a robot when the box reaches the end of the line. The robot may move the box to a pallet for shipping. There are plenty of demonstration videos on YouTube showing an amazing array of applications for robotic arms. A third piece of technology that is invaluable when we're starting to learn about robots is the understanding of computer programming. Now, there are several ways to go about learning computer programming, and there are many languages to choose from. And what I've decided to do is to offload that content into our next episode. So if you come back for that episode, it'll be a standalone because it's going to discuss, should I learn to program? And if I do learn to program, what language should I learn? And if I do learn a computer language, where should I learn it? So we'll get into all of that next time. It's going to work as a standalone for people who just want to look into computer programming, but any computer language can teach you things about how a robot might be programmed as well. So that's a very helpful place to dig in deeper than we can do at the end of this episode. And speaking of the end of this episode, we're also coming up to the end of our season here. So the next episode, which will be our 12th, will be the last for this season. We'll probably have a change of formats between the seasons. That just means we'll do deeper dives into each topic. Watch for announcements about that coming up. Watch for that next episode. Let everybody you know that listens to podcasts know to look for this one. And by all means, use that feedback form on the website. Let us know what you're interested in or if you have any further questions about some of the topics that we've already discussed. Thanks for listening. That's all we have for today. This is Dean saying thanks for listening, and we hope to have you back with us next time on Teachers to Tech.